Hello there, and welcome to your fourth video tutorial with reference variables and pointers. And in this video, we are actually going to start with reference variables. Guys, remember when I talked of pointers, I said that here, this is the memory. Right here, you have this thing called this thing is a variable. This is the memory address. I'm using a different convention this time when compared to what I used at that time. This is the size, this is the value, and right in here you have the name of the variable. It looks similar, but the convention I've currently used is slightly different. Anyways, let us assume the memory address is 0x72fc54 or something. The size is 4. The value is 85. It's an integer, 85. This is the memory address. Good enough. And right in here, the moment you declare a reference variable to this happens. More reference variables, more compartments, no problem. Anyways, we need only two right now. A. Say A was the name of the variable. Int A equals to 85. Anyways, let's take up int A equals 85. This is the situation represented by this system currently. Now reduce A. Cout A. It's a void function reduce int p minus minus. You know the output will be that A doesn't change, which in the example earlier it's still 85, because right in this case what happened was another memory block was allocated like this. It had a different memory address, the same memory size, I mean a different name, a different memory address. The situation which took place this time was P 0x765FCB 4 85. It got copied and it got reduced. So what happened now was this 85 was removed and now it had a value of 84, and this didn't change. But what if, what a reference variable is, this is a reference variable, a P. Right to the same memory address, I'll have another name with a different scope. So like this, if it changes, so this time this will update. How do I say? Send P. That's the only difference in the code, and I run it and see 84. And percent %p means that p is a reference variable to an integer, and a reference variable has to be initialized. You have to tell the computer immediately when you create the variable that where it has to make this p thing equals a for a, and you cannot change it now. Now I can say p equals 852, and then I can print out on the screen a, and out of this one and L, and an A, and 852. A becomes 852 because they are pretty much the same now. If I say P equals 852, okay, this is the value of E. Change it to 852. So whenever the user input calls A, it again refers to 852. That's simply the concept of reference variables. Such a memory block is not created. As you know, in case of a pointer, another block of memory was being created right here. It had a different name, it had a different memory address, it had a different size, and right here, like 0x72 something was stored. But in this case, a name is associated right here. So this is a reference variable, this is a reference variable, and that one was a pointer. So why to use pointers when reference variables are so easy to use? They are less memory consuming. So the question we were wondering on is why should we actually use pointers when they actually occupy memory and they are complicated to deal with, whereas reference variables are simple enough, just the initialization statement is different. Well, now why to use pointers? I can give a very detailed answer, but I believe this, but as per my experience, this is where I generally prefer not to use reference variables because of a reason. I'll just explain it. Now I won't be creating a reference variable to this, so I didn't make a compartment in there. Three, four. This is an array of four integers, so each will have a size of 4, and let's say this array is like named A. An array of four integers with a name A. And in case its memory address is 0x76FF40, array has continuous memory allocation. 0x76FF44, 0x76FF48, and 0x76FFC. Yeah, these are the memory locations it will have. So this will be A of 0, this will be A of 1, this will be A of 2, and this will be A of 3. Now when I write a command in the compiler, A of 2, what it that's so now what it does is it locates this A, which identifies this first element as A of 0, skips up, identifies it as A of 1, skips up, identifies it as A of 2. And now in memory, this can be A, right here it can be B, right here it can be C, right here it can be, okay, this it's not an overlap, right here it can be D, and so on. But the memory address is always continuous, which means if it encounters this address and it has to locate this address, it knows it has to go in this direction. So now if I write down int a equals 5429 and int star b equals basic and to send a 0,